Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello students, viewers, subscribers, and future engineers. Here is another video in Calculus 3.37 about derivative as slope. If you want to anticipate the solution to this problem, you may do so by pausing the video and just concentrate on the problems. A curve has an equation y equals f of x. Write an expression for the slope of the secant line through the points P with coordinates 3, f of 3 and Q with coordinates x, f of x. Then 1b, write an expression for the slope of the tangent line at P. Then 2, so let's concentrate on problem 1 first. So we know that slope is delta y over delta x, and delta y is y2. Let us say this is y2. This should always be the y sub 2 f of x minus y1 f of 3 all over delta x, which is x minus 3. So therefore, the slope of PQ, the expression for the slope of the secant line PQ is f of x minus f of 3 over x minus 3. So that's the answer to the first problem 1a. Then expression for the slope of the tangent line at P. The expression for the tangent line, for the slope of the tangent line at P is supposedly denoted by m, and dy dx, that's the limit of delta y over delta x as delta x approaches 0. Since we already set up this, then we just evaluate the limit of that. So limit as x approaches 3 of f of x minus f of 3 over x minus 3. So that's it for 1b. For problem 2, suppose an object moves with position function s equals f of t. Write an expression for the average velocity of the object in the time interval from t equals a to t equals a plus h. So expression for average velocity is change in displacement delta s over change in time delta t. And change in displacement is simply f of t plus, which is f of a plus h, that's the time, then minus f of t when t is a, so minus f of a over delta t, and delta t is a plus h minus a, and that is just h. So delta s over delta t, so f of a plus h minus f of a over h. So average velocity therefore is f of quantity a plus h minus f of a over h. Then to be, write an expression for the instantaneous velocity at time t equals a. That's the limit of the average velocity here as delta t approaches 0. When delta t approaches 0, h approaches 0 also. So v ds dt, limit of delta s over delta t as delta t approaches 0, since delta t is h, so that is when h approaches 0 also. So limit as h approaches 0 of f of quantity a plus h minus f of a over h. Then next, consider the slope of the given curve at each of the 5 points shown. List these 5 slopes in decreasing order and explain your reasoning. So all you have to do is approximate the slope. Remember that uh, positive slope is one that is sloping up to the right or down to the left. That's positive slope because the angle in counterclockwise direction is between 0 to 90 degrees, and tangent of any angle between 0 to 90 degrees, excluding 90 degrees because it is undefined, and angle between 180 and 270 degrees, the tangent is positive. So that's why it is positive slope with, or slope of a line that is pointing up to the right or down to the left. Zero slope is when it is horizontal, and negative slope when it is pointing up to the left or down to the right. So for instance, at A, the tangent line is approximated as shown. So I'll just approximate that this is one part and this is two parts, and it is a negative slope because it is pointing up to the left. So therefore, the approximate slope is negative 1/2, 1 over negative 2. So M at A is negative 1/2. Up B, so assuming this is approximately 2 units, this is 1 unit, but it is sloping up to the left or down to the right. So the slope is again negative 2 over negative 1 is negative 2. So the approximate slope at B is negative 2 approximately. At C, it is exactly 0. The tangent is horizontal, so 0 slope, that's exactly. At D, which is the reflection of B about this vertical axis of symmetry here. So I'll just, the slope is up to, the tangent is up to the right this time. So since we approximated the slope at B to be negative 2, so this is now positive 2. So 2, 1. Then at E, although E is the reflection at A also, supposedly the slope is the positive of negative 1/2, so 1/2 supposedly, but based on this approximation, I just call it 2 units, 3 units, or 2/3. Anyway, the slope is less than 1 definitely, but it is positive. So if we approximate this as 1/2 positive 1/2, that's fine. I'll just approximate this as 2/3 because of the limitation, because of the curve and the construction of the tangent line, which I just approximated here because there are no coordinates here. I just base it on the approximate angle of inclination. So 2/3 is fine, 1/2 is fine also. Anyway, that's approximate value. So therefore, in decreasing order, we should start at the highest and positive, so moment at slope at D. Then next is slope at E, because this is positive 2/3. Then 0 moment at C. Then MA negative 0.5, and the slope with lowest value is MB with slope negative 2. So that's the arrangement in decreasing order of the slope, and the explanations were already mentioned because of the approximate thing. Then 4, find the slope of the tangent line to the parabola y equals x squared plus 2x at the point negative 3, 3. So the parabola is open upward if you base it on the standard form of equation of parabola. For those who have not yet familiar with graphs of parabolas, you're supposed to familiar with this from algebra, supposedly. But if you're not familiar with it, then later on in one of my playlists in algebra or in analytic geometry, you can have there the standard form of equations of parabola so that you can sketch smoothly the graphs of parabolas. But if you're not familiar with that standard forms of equations of parabolas, then you can have point plotting as long as you know that it is open upward. Anyway, when x is 0, y is 0. When x is 0, y is 0, it passes through that. The vertex is, I transform it to the standard form. Then find an equation of the tangent line in part A, graph the parabola and the tangent line. As a check on your work, zoom in toward the point negative 3, 3 until the parabola and the tangent line are indistinguishable. So this is the parabola y equals x squared plus 2x. I'll complete the square in x at the right side. So I'll just interchange position. So x squared plus 2x plus 1. 1/2 of 2 is 1, then square it, so 1. I should also add y by 1 to balance. So this is a perfect square trinomial. X plus 1 square equals 1 times y plus 1. So the length of the latus rectum of the parabola is 1. And this is the standard form, x minus h quantity square equals length of latus rectum y minus k. So the parabola is open upward based on the standard forms and with vertex at x minus negative 1. So negative 1, comma y minus k. So k is also negative 1. So the vertex is at negative 1, comma negative 1. If you do the point plotting, you have to plot uh, values of negative 3, then solve for y, negative 3 square, 9 plus 2 times negative 3, 3. So that's why you have here negative 3, comma 3. Then negative 2, comma 0. Then negative 1, comma negative 1, the vertex. Then 0, comma 0. Then 1, comma 3 here. Then you just extend the parabola. Then that's the shape of the parabola. So the slope is the derivative of x squared plus 2x. So dy dx is 2x plus 2. And since the point in question is at negative 3 comma 3, so slope is 2 times negative 3, x is negative 3 plus 2, so the slope is negative 4. That's why it is pointing up to the left. So that's a tangent line, this blue line here with slope negative 4. The equation of the tangent is equation of line y minus y1 is slope times quantity x minus x1. This is point slope form of equation of a line. So the y coordinate is 3, so y minus 3 equals slope negative 4 quantity x minus x1 negative 3. So y minus 3 is negative 4x minus 12. Simplifying, the equation of the tangent is y equals negative 4x minus 9. And this is the graph. This is the tangent. And let's zoom in at negative 3 comma 3. So that's y equals x squared plus 2x. Then let's zoom in that point. Then the tangent line really is almost coinciding with the curve, the red curve here. So that shows that that's really the tangent. So that's it for this video. I hope that you were able to understand the explanations and the solutions.